Today we're going to be looking at linear programming. So linear programming is a technique to identify a minimum or a maximum value of some quantity. The objective function is a function used to determine the minimum or maximum. The constraints are limits on the variable, so inequality is used to find the vertices. And the feasible region contains all points that satisfy the constraint. So we look at this first example. Our constraints are each of our inequality equations we have. So each of these lines are our constraints, and the feasible region is everything inside of these 4 points. So let's take a look. This feasible region contains point 50, 0, 80, 80, 0, 40, and 10, 20. So if we want to find the maximum value for the objective function, our objective function is this. So we want to plug that in for each one. So we have 5 times 50 plus 2 times 0. And we do 5 times 80 plus 2 times 80. 5 times 0 plus 2 times 40. 5 times 10 plus 2 times 20. Alright, so if we solve this, 5 times 50 equals 250 plus 0. So we know this one is 250. 5 times 80 is 400. Plus 2 times 80, 160. So if we add 400 plus 160, it's 560. 5 times 0 is 0. 2 times 40 is 80. 5 times 10 is 50. Plus 2 times 20 is 40. So the one that maximizes the vertex is 80, 80. And the maximum value is 560. So number 2, we want to graph our feasible region and find the maximum vertice for this function. So first of all, I need to rewrite this so it's in slope-intercept form for me to graph. So I subtract x to both sides. 2y is less than or equal to negative x plus 8. Divide each side by 2. So y is less than or equal to a negative 1/2 x plus 4. So if I graph this equation, I'm at a positive 4 on my y-axis, and my slope is negative 1, 2. So here's my first one. So my shading, since it's less than, I'm looking at, if I plug in the points 0, 0, oops. So is 0 less than or equal to 4? Yes, it is. So since that point's below, I'm shading everything below. So I'm going to look at x is greater than 2, or equal to. So here's that. So that means x is greater than or equal to 2, so that means it's everything on this side. And our last one, y is greater than 0. So that means we have this equation, and it's greater than 0. So that means we are looking at the feasible region right there. And our 3 vertices, we have 0, 0. We have 2, 3. We have the feasible region 8, 0. So we need to find the maximizing value for this objective function. So we're doing 0 plus 3 times 0, 2 plus 3 times 3, and 8 plus 3 times 0. So 0 plus 3 times 0 is 0. 2 plus 9 is 11, and 8 plus 0 is 8. So our maximum vertex is 2, 3, and the maximum value is 11. Let's look at a few more. So let's graph our first equation. We have y is a negative 3. Our slope is 3, 2. So here's our first one. So to figure out what shade we are shading on, I'm going to pick the point 0, 0. So if I plug in a 0 and a 0, is 0 greater than or equal to a negative 3? Which that is true. So I want to shade this side. Alright, so now let's graph y is less than or equal to negative x plus 7. So I'm at 7, slope is a negative 1. So I'm going to connect that. So if I plug in a 0 as well, 0 is less than or equal to 7, which is true. So I still want to shade in this area. And my last ones, x is greater than 0, so that means our x value has to be bigger. So we're in here. And y has to be bigger than 0. So now we're looking at this feasible region. So we have 4 points. We have 0, 0, 2, 0, 4, 3, and 0, 7. So in order to maximize our function, let's plug those in. So we have 3 times 0 plus 2 times 0, 3 times 2 plus 2 times 0, 3 times 4 plus 2 times 3, 3 times 0 plus 2 times 7. So 0 plus 0 is 0, 6 plus 0 is 6, 12 plus 6 is 18, and 3 plus 4, or 0 plus 14 is 14. So our maximum vertex is 4, 3, and the maximum value is 18. 2 more examples. So we have x is greater than or equal to 0. So that means we're greater than or equal to 0 on this side. Y is greater than or equal to 0. So we're in this chunk now. Y is also less than or equal to 3. So that means we're down below here. So then our last equation, we need to write it in slope-intercept form. So subtract x. So y is less than or equal to negative x plus 5. So we're at 5. Slope is 1. So our feasible region in this one is this trapezoid. So our 4 points, or vertex, are 0, 0, 0, 3, 2, 3, and 5, 0. So we want to find the maximum for this function. We do 5 times 0 plus 8 times 0, 5 times 0 plus 8 times 3, 5 times 2 plus 8 times 3, 5 times 5 plus 8 times 0. So this one equals 0. 0 plus 24. 10 plus 24 is 34. And 25. So our maximum vertex is 2, 3, and the maximum value is 34. I want you to try the last one on your own.